Ancient Greek astronomy laid the foundation for much of Western astronomical thought. Greek philosophers and astronomers made significant contributions to understanding the cosmos, blending observation, mathematics, and philosophical reasoning. Among these thinkers, Aristarchus of Samos stands out as an early proponent of the heliocentric model, a revolutionary idea that preceded the Copernican system by almost 2 millennia. This video explores the development of ancient Greek astronomy and Aristarchus's groundbreaking contributions. Greek astronomy had its roots in earlier civilizations, including the Babylonians and Egyptians, who provided observational data and calendrical systems. However, the Greeks distinguished themselves by seeking rational explanations for celestial phenomena rather than relying solely on mythological or supernatural interpretations. The earliest Greek contributions to astronomy can be traced back to the Pre-Socratic philosophers of the 6th century BCE, such as Thales of Miletus, who proposed that celestial bodies followed natural laws rather than divine will. Pythagoras and his followers introduced the idea that the universe was governed by mathematical principles. They believed in a harmonious, ordered cosmos where celestial motions followed numerical relationships. The Pythagoreans proposed that the Earth was a sphere and that celestial bodies moved in circular orbits, laying the groundwork for later Greek models of planetary motion. Plato significantly influenced Greek astronomical thought by emphasizing the perfection of circular motion. In his dialogue, Timaeus, he argued that celestial bodies moved in perfect circles because circular motion was the most perfect and divine form of movement. Although Plato himself did not develop a detailed astronomical system, his emphasis on circular motion heavily influenced later astronomers, including his student Eudoxus of Cnidus. Eudoxus of Cnidus developed the first systematic geocentric model, which placed the Earth at the center of the universe. His model consisted of concentric spheres, each carrying a celestial body, with different rates of rotation to account for observed planetary motions. While Eudoxus's system did not perfectly match observations, it represented a significant step in the mathematical modeling of the heavens. Aristotle expanded on Eudoxus's ideas, integrating them into his broader natural philosophy. In his work On the Heavens, Aristotle argued that the universe was composed of concentric spheres with Earth at the center. He also distinguished between the sublunary realm, where change and decay occurred, and the celestial realm, which was composed of an unchanging ether. Aristotle's model became the dominant cosmological framework for centuries, influencing both medieval and early modern thought. Hipparchus of Nicaea was one of the most accomplished astronomers of antiquity. He developed a highly accurate star catalog, measured the precession of the equinoxes, and refined models for the motion of the sun and moon. Hipparchus introduced the concept of epicycles to explain planetary motion, paving the way for Ptolemy's later refinements. Claudius Ptolemy synthesized Greek astronomical knowledge in his seminal work, the Almagest. His geocentric model, which employed epicycles, deferents, and equants, provided an accurate predictive system for celestial movements. The Ptolemaic system dominated Western astronomy for over a millennium until the heliocentric revolution of the Renaissance. While most Greek astronomers adhered to the geocentric model, Aristarchus of Samos proposed a radically different idea, that the sun, not the Earth, was at the center of the universe. Aristarchus's heliocentric model suggested that the Earth rotated on its axis and orbited the sun, a concept that anticipated Copernicus's heliocentric system by nearly 1800 years. One of Aristarchus's major contributions was his attempt to determine the relative sizes and distances of the sun and moon. By observing the angle between the sun and moon during a half-moon phase, he estimated that the sun was much farther from Earth than the moon. Though his calculations were imprecise due to observational limitations, he correctly inferred that the sun was significantly larger than Earth, which may have led him to question the geocentric model. Despite the logical appeal of Aristarchus's heliocentric theory, it was not widely accepted in antiquity. The geocentric model had strong philosophical and observational support, particularly in Aristotle's physics, which posited that the Earth was naturally at rest. Additionally, The lack of observed stellar parallax was interpreted as evidence against a moving Earth. Although Aristarchus' heliocentric theory did not gain widespread acceptance, his ideas were preserved and later influenced Renaissance thinkers. The rediscovery of Greek astronomical texts during the Renaissance, including those discussing Aristarchus's model, helped inspire Copernicus' development of the modern heliocentric theory. Ancient Greek astronomy represents a critical period in the history of human understanding of the cosmos. From the mathematical innovations of the Pythagoreans to the sophisticated planetary models of Hipparchus and Ptolemy, Greek astronomers sought to explain celestial phenomena through logical reasoning and observation. Aristarchus of Samos, though largely ignored in his time, proposed a heliocentric model that foreshadowed modern astronomy. His contributions, alongside those of his predecessors and successors, exemplify the intellectual rigor and curiosity that defined Greek scientific thought.